Hello everyone, welcome to Arduino and My Robot. This is chapter 5, and in this chapter we'll be learning about the basic electronic components. So you see we have covered breadboard, and this is a basic layout how a breadboard can be used, and this is a complex layout actually, but this is where you'll see how a breadboard can be used to connect different components of a how to connect different components on Arduino, and this breadboard is a best example to use. Okay, so the first component that we'll be covering is register. So a resistor impedes the flow of electricity through a circuit. Impedes means or reduces, or you can also say it as controls the electricity current flow through the circuit. Circuit means through the wire. Okay, so resistor have a set value. You can see this strips: golden strip, brown strip, purple strip, and yellow strip. These have some values, and that can be used to calculate the complete resistance value of this resistor. Okay, when I say resistor, it is basically adding a resistance to the electricity flow. So when somebody is walking on the or driving on a road, you see speed breakers. So speed breakers are used to reduce the speed of any driver. So same way resistors are used to reduce the amount of current flowing through a given circuit. Okay. Since voltage, current, and resistance are related through Ohm's law, resistors are a good way to control voltage and the current in your circuit. So what is an Ohm's law? So this was a law: I is equals to V by R, and that law was basically given by Ohm, and so we use it for controlling the current. So we write as I is equals to V by R. So R is resistance. So R is related with current. If we increase the resistance, the current will decrease. Inversely proportional. Okay. And this is the symbol for any resistor, just like a speed breaker. The next one is variable resistor or potentiometer. So this is also same, and the length of register here, this up and down. So this arrow is showing what is the length. Effective length means what is the number of ups and down that will be actually reducing the current value. So here we have three peaks: 1 2 3 4 5, sorry, 1 2 3 4 5 6. So this speed breaker having 5 bumps, and this speed breaker with this arrow, that we have to count up to this point. So we have 1 2 3 4 bumps. Okay, so in this case there will be less resistance, and in this case there will be more resistance. So if we want to increase or decrease our resistance, or uh, if we want to reduce the current or increase the current, we'll be using this. So now the formula is by Ohm's law, I is equals to V by R. So to increase R, we have to increase V. V and R, these are directly proportional. Okay. Directly proportional means when one increases, the other also increases. So we can rotate from this knob. Okay. And by rotating the knob, we'll be moving this arrow point, and this will decide the amount of current that is passing through. Okay. So since we are able to change the resistance, this is called as variable resistance resistor or potentiometer. Next is capacitor. You can consider capacitor. I think you might have seen these small things mostly, or at least these things in your TV remote or any electronic gadgets. Okay. So these are mini power banks. Okay. You might have seen power bank. When you discharge your phone, you take a power bank and charge it. Only thing or only difference between a power bank and this is it will not be storing the current for long. As soon as you connect it with some component, it will give all its stored current at once. Like suppose I'm having 1,000 rupees. Okay. Consider my rupees as my current. Okay. So now I go to market. If as soon as I see anything to buy, I'll buy anything that is of 1,000 rupees. Okay. I'll not buy for 50 rupees, then 100 rupees, then 200. Not like that. I will completely give away my 1,000 rupees and buy anything that is of 1,000 rupees. So you store in this for a certain period of time. And as soon as you connect with this component, it will give away all the current to that part. So the best thing that I can show you is it you can see these capacitors in every fan, right? Or the tube lights. If you see old tube lights, you can see a small, this kind of thing, white color thing. Even in the fans, you can see this is in white color that is used as capacitor. So these capacitors store electrical energy. This pool of electrons is available for electronic components to use. The capacitance is measured in farads. So this capacitor is having what amount of current it is having, that is measured by unit farads. So the small capacitors usually used in electronics are often measured in microfarads and nanofarads. One end will be negative and other is positive. As I said, every component will be having one negative end and other as a positive end. Same as in this case. Now you see, this is the symbol of a capacitor. Okay, one end is positive and other is negative. Then we have diode. In diode also we have one end as a positive and other as a negative. This is diode symbol on the right side, and this is our figure of a real diode. Okay. So a diode is a one-way valve or a gateway. So it's like one-way road. Okay, you can go from only one direction. You cannot come back from that road. You can only go. You cannot come back. So it is a one-way for electricity. Electricity can only go through it but cannot come back. So it is a component with an asymmetrical transfer characteristics. A diode has low resistance when you consider it as a normally, so it will have a zero resistance. It will not, resistance is hindrance or opposition to flow. Okay, so this diode will have zero resistance. When we say ideally means that is basically not true. There is nothing ideal, but if we consider it as ideal, this resistance in a diode is zero. But in one direction. In one direction, resistance is zero, and in other direction where the current is not. Why the current cannot flow in other direction? Because in that direction there is a very heavy resistance. Okay, it is like if you go from one room to other room from one side, there is no guard. But if you come back, there is a police or guard standing on that road. You cannot come back. So what happens by using this? Suppose there is a backflow of current, so it will protect your electronics. It will not allow your electronics to burn or fry off. Okay. If the polarity is wrong, the motor will run backward. Suppose if you have connected it opposite, like how to know, like I have connected it wrong or right. So if suppose your rotor or the motor is to rotate in forward direction, if you connect it opposite, the motor will not work in forward direction. The current will only flow in one direction, so it will start moving in backward direction. In electronic circuit, if the polarity is wrong, you can completely fry your components. Okay, so be cautious in which direction you are adding any component. Then we have LED. This is the most common electronic component that and I can bet everybody might have seen it. Okay, everybody has seen it. If not, you have LED bulb in your room, and if you open that white top of it, you can see multiple these kind of LEDs inside it. Okay, miniature LEDs. So LED means light emitting diode. So this is based on a semiconductor device. This is a semiconductor device. Okay. So when electricity is passing through the diode, it emits light. Okay. So this also has one positive end and one negative end. So this is a diagram symbol for LED. So the positive symbol is called as anode and negative symbol is called as cathode. So now we have a DPDT switch. Switch is basically, turning on and off. So DPDT means a double pole double throw switch is a switch that has two inputs and four outputs. You can see four pins here and two pin in the center. Okay. Each input has two corresponding output that it can connect to. Each of the terminal of a double pole double switch can either be in one or two positions. This makes the double poles double throw switch a very versatile switch. So you can use it in as a two-way switch. Okay. We'll be understanding how to use it when we'll go for the project, and which switch to use, we'll be understanding it there only. So what is a transistor? So transistor is a semiconductor device used to amplify and switch electronic signals and electrical power. This is our electronic switch. This is our electronic switch. You can see we have three legs here. If you have not seen this, I can bet you have seen this at least. So this is a semiconductor device that will be amplifying, means to increase or enhance the signal. Okay. Or sometime we'll need to switch this between different signals. So we'll use transistors. So we have IC circuits. Integrated circuits is a set of transistors that is controller or the brain of electronic circuits. An input is received and output is sent out. A modern microprocessors ICs can have billions of transistors per square inch. Okay. So this is a microcontroller and it has multiple ICs inside it. Okay. Integrated circuits. So billions of electronic controlled on and off switches. When I say switches in this electronic circuit here, this is like this. So these are like billions of electronically controlled on and off switches or transistors is how the microprocessor in digital computer thinks and functions. So let's understand what is I'm trying to say. Uh, there is a voltage output and it passes through your IC circuit, and that from there it goes to motors as a command. Okay. Op amp, an operational amplifier, is a set of transistor inside the integrated circuit. They are often they often are the components doing the mathematical operations. So if you have any coding operation which require mathematical part, so that will be taken care by this component. Okay. This is called as op amp. So now we'll be covering the steps. So there are a couple of reasons we do not use just a potentiometer to control the speed of our motors. Suppose if you would be thinking like, I can control the current and then control the speed of our motor, then we can use potentiometer or variable resistor. No, that is not a good idea. Potentiometers are rarely used to control significant power. You would still need a way to switch the direction of the motor. Just using a potentiometer can control the speed but not the direction. Okay. Suppose I'm moving my wheel in the forward direction, but I have to move my car backward direction. So in that case, I can reduce the current to stop my wheel or reduce the speed, but I cannot turn it in backward direction. So using a potentiometer or a variable resistor will not be a good option. Okay. DP-DT switch and potentiometer combinations can lead to problem if you quickly switch off and switch on. Okay. So this could be a problem when you are trying to do reverse. So this combination, you should be very like careful when you use potentiometer with a DP-DT switch. And that problem is due to the polarity switch. Okay. Like the positive and negative terminals switch between each other. So this could affect the motor. So the next thing is circuit board, PCB, right? Printed circuit board. So I suppose everybody have seen this. So this is a circuit board on, and this is where we'll be connecting different components. This is a connection, and these are the points where different components will be soldered. Okay, this is a like something like a breadboard. It is used for connecting different components, electronic components, similar to breadboard. And that's all for the component part. Thank you very much.